Let's continue on our discussion of differentiation of basic functions. Let's look at the trig functions. The starting point for these is obviously sine and cosine. The proofs of what the derivatives are a little bit technical. You can follow them up in the textbook. We'll just motivate it here. Let's start with the graphs of sine and cos. If we start with the graph of sine x, let's see if we can figure out what the derivative of sine x is. So let's start at the origin. At the origin, the gradient of sine x is the slope of the tangent line at the origin. And that looks to have a slope of about 1. So if I put the slope here, mark it on this graph below, the slope of the sine x at x equals 0 is about 1. Let's do some easy points on it. The slope here at pi by 2, the slope of this tangent line is 0. So if I drop that down to this lower graph, the slope is 0. Then at this point pi, x equals pi, the slope is minus 1. Let's drop that down on this graph here. And if we get to 3 pi by 2, we get back to a slope of 0, and so on. So it seems plausible anyway that the derivative of sine x is equal to the cosine of x. Now let's consider this in reverse with cosine of x. Again, we'll do the same thing. So we'll start at the origin, where the function's horizontal. The tangent line to the function is horizontal, so that has a slope of 0. And let's map that up to this top graph here. Then if we move along to x equals pi, we have a slope of minus 1. So let's stick that on this graph here. If we move along to pi, we have a slope of 0. And 3 pi by 2, we have a slope of 1. And then back to 2 pi, we have a slope of 0 again. The derivative of cos is obviously not sine x, but if we flip the sine x graph upside down, that is, look at minus sine x, that looks like it should fit. And in fact that is the case. The derivative of cos is minus sine x. In the textbook you'll be able to find a derivation of this directly using the definition of the derivative and some limits. So from these fundamental rules, all the other derivatives of all the other trig functions follow. So, for example, the derivative of tan x just becomes, this is equal to, first term is obviously just 1, and then we have plus sine x. The derivative of 1 over cos is the same as the derivative of sec x, and that's equal to minus 1 over cos squared x times the derivative of cos, which is minus sine x. So this then becomes 1 plus tan squared x. Okay, or using trig identities, this is equal to sec squared x. Derivatives of all the other trig functions follow in the same way. We can also calculate things like trig functions of trig functions. How do we do that? Well, we just use the chain rule. So this is the derivative of sine, which is cos, times the derivative of tan x. And so this is just cos of tan times sec squared x, and so on.